Hello friends, welcome to ECE Academy. In this lecture, let us understand superposition theorem. Superposition theorem states that in any linear network with two or more independent sources, the current or voltage in any element is the algebraic sum of the current or voltages produced by each source acting alone, with all other independent sources replaced by their internal resistances. So, in brief, we can say we need to find the voltage and current by taking into account only one source at a time. Then we need to take the algebraic sum of the voltages and current that will give us the value of total voltage and total current in the circuit. Here, you need to remember while doing superposition theorem, the voltage sources are replaced by short circuit and the current sources are replaced by open circuit. Then we can do the calculations. Now, let us consider this circuit. In this circuit, we are having two voltage sources. So first, let us consider 8 volt and let us short circuit 10 volt. Let us make 10 volt to 0 and let us find the current flowing through the 6 ohm resistance. Let us call that current as I1. Then we'll make 8 volts 0 or we'll short circuit the 8 volt source and we'll consider 10 volt and we'll find the current through 6 ohm resistance, that is known as I2. If we take the algebraic sum of I1 and I2, we should get the total current flowing through the 6 ohm resistance. Later, we'll verify the superposition theorem by applying KVL to this circuit. Now, in the first case, let the 10 volt source be set equal to 0. So, we need to short circuit this and we need to redraw the circuit. So, the circuit reduces as shown in this figure. Let us take I1 as the current through 6 ohm resistor. Here 8 volt source acts alone. In this circuit 2 ohm and 6 ohm resistors are in parallel. So combined resistance will be 2 ohm parallel with 6 ohm. So if you apply parallel formula for this, so it will be 1 by 2 plus 1 by 6 inverse. So the parallel resistance will be 1.5 ohm. So this equivalent 1.5 ohm resistor will be in series with 8 ohm resistor. Therefore, the total circuit resistance will be equal to 1.5 ohm plus 8 ohm, that is equal to 9.5 ohm. Therefore, the total current will be equal to V by R. Here V is equal to 8 volt divided by R is the total resistance, which is 9.5. So this will be equal to 0.8421 amperes. Now the current through 6 ohm resistance is I1, that can be given as, since we are finding current here, let us apply current division rule. Resistance in other branch is 2 ohm divided by sum of the resistances is 8 ohm multiplied by total current. So I1 will be equal to 2 divided by 2 plus 6 multiplied with 0.8421. Therefore, I1 is equal to 0.2105 amperes. Now let us take the second case. Let 8 volt be set equal to 0. Now if 8 volts is set equal to 0, this is the simplified circuit where we are having only single voltage source that will be acting on this circuit. Now we need to find current I2 that is flowing through the 6 ohm resistor. In this circuit, as 6 ohm and 8 ohm are in parallel, therefore we can say 8 parallel with 6 ohm. So this will be equal to 3.426 ohm. Now this 3.4 ohm is in series with 2 ohm. Therefore, total circuit resistance will be equal to 3.426 plus 2 ohm. So total circuit resistance will be equal to 5.426 ohm. Therefore, the total current through the circuit will be equal to V by R. So the source voltage is 10 volt divided by total resistance is 5.426 ohm. So this will be equal to 1.8421 amperes. So to find I2, we can take the resistance in other branch divided by sum of the resistances multiplied by source current. So I2 will be equal to 8 divided by 8 plus 6 multiplied with 1.8421. Therefore, I2 will be equal to 1.05256 amperes. So this is the value of I2 and this is the value of I1. Therefore, total current in 6 ohm resistance will be I1 plus I2. So let me write here total current I will be equal to I1 plus I2. Therefore, I will be equal to 0.2105 plus 1.0526. Therefore, the current through 6 ohm resistor will be equal to 1.2631 ampere. Now let us verify the superposition theorem. Now let us consider the current through first branch as X and the current through second branch as Y. So these two directions are written based on the voltage source that are connected. Now let us find the individual currents X1 and X2 by using KVL, and then we can add these two current and we can find the total current flowing through 6 ohm resistor to verify the superposition theorem. So let us apply KVL to the loops. Therefore, for the first loop, we can write 10 minus 2x minus 6 into x minus y is equal to 0. Now, we can write the above equation as 8x minus 6y is equal to 10. After simplification, let us call this as equation number 1. Now for the second loop, if we apply KVL, we can write 6x minus y minus 8y minus 8 is equal to 0. Therefore, we can write 6x minus 14y is equal to 8. After simplification, let us take this as equation number 2. Let us solve equation 1 and 2, and we can find the value of x and y. So after simplification, you can use calculator to simplify. We'll get x is equal to 1.2105 and y is equal to minus 0.0526 amperes. Now if we observe the circuit, the current x and y are flowing in the opposite direction across the resistance 6 ohm. So we can write the total current through 6 ohm resistor can be given as x minus y. So the value of x is 1.2105 minus of minus 0.0526. So the total current will be equal to 1.2631 amperes, which is same as what we got using superposition theorem. This is about superposition theorem. You can use the same concept to solve any problems. Hope you have understood the topic. Thank you.